Hello the internet and welcome back to my channel. Today on the bench I have a Sinclair ZX Spectrum. This belongs to one of my viewers, Becca. Hello Becca. Becca brought me two ZX Spectrum. I fixed one in a previous episode, feel free to go and take a look, and this is the second one of the batch. Now as the other one, I don't know what works and what doesn't on this one, so we'll take a look together. Now, if I take a look inside of the ZX Spectrum, this is another issue 2 board, and this ZX Spectrum is equipped with the full 48 kilobyte of RAM, even though there's something that caught my attention on this ZX Spectrum, besides the missing ULA, which I had to use for the other ZX Spectrum because the other one was faulty. What I'm talking about is this little daughter board here, and I had a look around and it looks like this is from the factory. Now this is the lower 16 kilobytes of RAM, this is standard with any ZX Spectrum, while to have 48 kilobyte you need this extra 32 kilobyte of RAM in this position here. Now these modules are actually 64 kilobytes of RAM, but only 32 kilobytes of RAM were being used. And why is that? Because these are actually faulty modules. Basically, Sinclair, to try and reduce the cost of the unit, was getting faulty modules from the manufacturer and only using either the upper part or the lower part. And obviously all these modules have to match, so you can't mix and match upper and lower broken modules. Now nowadays obviously the cost of the memory is not a problem, so you just replace with a fully working one and you're only using either the top or the bottom. But when it comes to OKI RAM, I understand that the addressing is a little bit different. You can't use that like the upper or the lower, you have to use like the right hand side or the left hand side of the module, something like that. And in order to do that, you need to change the addressing, and in order to do that, Sinclair installed this little daughter board here which rewires the IC which is behind it and makes the OKI RAM compatible. Now the plan for this ZX Spectrum is to test it. I really don't know what works and what doesn't. I will grab the ULA from the other ZX Spectrum. I only have one which works, so we'll grab that one, at least we know it's working. Then we'll replace all the capacitors. Being a ZX Spectrum, we know that that's really required. We have replaced the voltage regulator with a modern one which doesn't transform the things in a small oven, and we will also replace the speaker because I believe I checked it on our previous episode and the speaker wasn't working either. First thing first, I'll remove the board from the shell and add a composite mod because I haven't got any RF monitors or anything. It's going to be temporary as the previous unit. Becca would like to keep it with the RF modulator to be used with CRT televisions. And on this occasion I won't have to do any rewiring for the diagnostic ROM, as I made myself these external ROM PCB with a nice diagnostic ROM on top, and as you might imagine this comes from this video sponsor PCBWay, and more of that in a minute. So let's remove the board, let's do the composite mod, and let's see if this ZX Spectrum even turns on. Composite mod is done. This time I ended up with the transistor mod. The reason is I have a new capture device and I know it likes everything I'm doing but the ZX Spectrum, so I'm curious to see whether the transistor mod is a bit more compatible with that one. We'll check in a minute. As I said, the ULA is coming from the other ZX Spectrum, so I know it works. Let me use some contact cleaner on the socket. And I guess we're ready to test in 3, 2, 1, go. Oh, okay. We got something. Ugh. Well, the good news is it seems to be working. Obviously we need to test everything, and the bad news is that even this new capture device doesn't seem to like something I'm using here, but it is working, it's getting better for whatever reason, and that's good. I would say let's quickly check the voltages to make sure that everything is fine. We got 10 volts in at the regulator and 4.9 volts out, so that is totally fine, and I believe we can check the voltages on these RAMs somewhere. Minus 5 volts is fine, again it's within specs, it looks awful but it's within specs. 12 volts digital is fine, and obviously 5 volts is also fine. The next step would be to plug my diagnostic ROM and check all the RAM, do all the tests and see if there's anything that doesn't work. I should have the Retrolium diagnostic ROM running on that external ROM, so let's power up and let's check the RAM. 3, 2, 1, go. Oh, okay. And would you look at that? This seems to be working. Well, there's quite a lot of things to do, don't get me wrong. But at least this is like basic of the system is working. Now, the next step, besides running more memory tests, would be to test that keyboard, because I know that those rubbery keyboards can fail pretty easily. So let me power this off, plug the keyboard, and then we'll use the keyboard test to see whether the keyboard actually works fine. Now, one problem I'm seeing with this keyboard is that these, let's call them connectors, I don't know. I think they were supposed to have some rigid backing at the back of the thing, which has probably broken or snapped. You can see this one has actually detached. And that makes plugging this in more or less impossible, because this is like soft plastic, or flexible plastic at least, and it's going to be pretty difficult to plug them in. I'll do my best, but it's not easy. And it's pretty much impossible, and I feel that if I keep trying, I will damage the ribbon cable. Now, just so that you understand what I'm talking about, I've just realized that the other ZX Spectrum still has a fully functional ribbon cable. As you can see, this flat cable has this plastic backing at the back, which makes the whole connector kind of not easy to flex. And that makes it easy to plug into the socket on the board itself. So I'll find something just to glue at the back to restore the stiffiness of the ribbon cable itself. Alright, so I found these two pieces of plastic. They are kind of stiff, but they're not very thick. These are coming from a cheese box. Nice way to recycle it. And this one is fitting here perfectly fine in the small connector here, and this one is fitting in this bigger connector here. So the plan is to use these glue I have here. It's a super glue Loctite 406. It's for plastic and rubbers, so that should be suitable for what I want to do. And the idea would be to attach some of the stiffer plastic on one side of the cable here, let it cure perfectly fine, maybe trim some excess at some point, and then hopefully that will be it and it will be ready. Right, the plan worked and didn't work. Let me show you what I mean. The stiffer plastic has adhered pretty well. It might need to be bent a bit with some hot air. The thing is, I completely forgot that these connectors here, on this one the contacts are facing my side, on that one the contacts are facing that side. And I put the plastic on the same side of the cable. So on this cable here, I actually put the plastic on top of the contacts. Oh my gosh. So I'll try and recover this one, otherwise I'll have to replace the membrane. My bad. I'll see if I can fix it. Nope. Well, what I'm learning from this project is that those connectors are very fragile. They can be wiped off pretty easily, at least the old one. I'm not sure whether there is a newer version now available, because I can see that while on this one I have full continuity from top to bottom. On this finger here, I don't. It starts like here. Yeah, I guess I can trim an extra little bit and see if that's still long enough to fit in the connector. Okay. Well, I'm not particularly optimistic, but let's power this up and see if by any chance this keyboard is doing anything at all. 3, 2, 1, go. Dead. Well, I'm not sure what happened here, but I haven't got signal from anything anymore, and even without the keyboard, and it was working before. Oh, my ground video lid has detached. Well, that's an easy fix. Right, let's try this again. 3, 2, 1, go. And it is working, besides the capture device not liking it. It's fine. So, well, that was an easy fix. Let me try and fit this keyboard again, and we'll see if it works. And no, there is not much that works. The number 6 works. So I'm assuming these will need a brand new membrane, which I think they're still available. Well, I think I found what the problem is with these keyboard. I think the problem is on these connector here, where there is a breakage here, where basically was at the end of the connector. Because if I'm checking continuity, I have continuity on the, let's call it the front part. But if I'm checking after what looks like a breakage, I don't have continuity anymore. Now, what I can do, because I have the plastic backing, which is, you know, pretty nicely glued to the cable, I can trim that part, and hopefully I will have enough slack on this cable here, and maybe the keyboard will start working again. Okay, here we are. Let's give it a go. Number 1. Number 1 still doesn't work. Number 2 does work. How well it works, I don't know, because I should try number 1. Number 3 works, so the keyboard is definitely doing a bit better. Now, unfortunately, number 1, which is the keyboard test, doesn't work. Number 0 also doesn't work. I would say we need a new keyboard here. Well, we need a new membrane. So I'll speak with Becca and see if she's happy to replace this. It's kind of a known issue with these machines anyways. It's actually pretty rare that the keyboards, these rubber keyboards, still work on these ZX Spectrums. This is the keyboard from the other ZX Spectrum, and I was able to get into the keyboard test. And everything works, so there's nothing wrong with the board, we just need a new membrane. One of the viewers of my previous ZX Spectrum repair video suggested that one of the reasons why the voltage regulator was getting really hot could also be because of these old capacitors. Now, when capacitors get old, they might short, and that's definitely not the case here because the board is working. But before that happens, they might develop a parallel resistance value. That means the capacitor is leaking voltage and is basically dissipating power for no reason, and that's power that the voltage regulator has to supply even though it's not going anywhere, just being dissipated in heat. So what I'm curious to see here is whether there is any difference with these old capacitors and afterwards when the new capacitors are fitted. So what I've done here in the spaghetti junction is I'm getting the voltage coming from the power supply, it's going through my multimeter, which is set into current mode, and then it's going back to the ZX Spectrum. What I'm going to do, I'm going to power it up, run the diagnostic, and we can read the current being drawn by the ZX Spectrum with these old capacitors. We will replace the capacitors and we'll repeat the test with the new capacitors and see if there's any appreciable difference within the current being drawn by the unit. We got about 750 milliamps, it depends what the ZX Spectrum is doing. And I would say the ZX Spectrum is drawing something in between 700 and 750 milliamps, depending on what the unit is doing. So again, we'll repeat the test with the new capacitors and see if there's any change. And the next step is obviously replace all the capacitors. I've got this nice little kit from Retrolium in the UK, blue capacitors, axial capacitors, so they will fit perfectly fine. As I said in my previous videos, because of the temperatures that exist within the case when the unit is running, this capacitor will be more or less gone, so it is really a good idea to replace them all regardless. So let's go ahead. Capacitors have been replaced. I've got C47 in my component tester. This is the one close to the heatsink, so it's the one which is getting pretty hot. And it's reading 30 microfarad, 7.1 ESR. This is a 22 microfarad, so it should only read something about 26 maximum. So it's definitely out of specs. The ESR is very low, and that's it. That's what, just to show you that it is a good idea just to replace all those capacitors regardless. First things first, let's make sure that this unit still works, and then we'll check the power consumption as we did before. 3, 2, 1, go. Okay, well, everything still works totally fine, so let's plug my multimeter and see how much power this thing is drawing now. And I would say the situation has definitely improved, because I think before it was between 700 and 750. Now I would say it's between 680 and 720. And when it was idle on the screen, I think it was 730. Now we have 700. So there is definitely an improvement. I don't think that's gonna make a massive difference with the voltage regulator here, but it's definitely a good thing to see on the multimeter. Thank you for the viewer who mentioned that. This is quite an interesting test, and it's nice to see this kind of improvement. This external ROM PCB works really well. It features a 412 kilobit ROM here, which means it can contain up to 4 different ROMs, which can be selected using these 2 switches here. And it also features a reset button, which is pretty handful. This, as you might imagine, it's an open source project. You can find the link down below in the description, and it was really fun to make it and put it together, get all the ICs, the sockets, the components, and solder it together. It's nice when you see these things, coming to life when you plug it into a device and they actually work. If you would like one too, well, PCBWay can help you. It's very simple. You just need to find the Gerber file of this project and upload it on PCBWay.com. It's pretty simple. The system is more or less automatic. I like to change the color of the boards on my project. As you can see, they're mostly red, not all of them, but I like them red. And then you choose your postal service, and PCBWay will deliver the PCBs at your place. Don't forget that PCBWay also offer other services like 3D printing, metal sheet fabrication, and what was the other one? Don't forget that PCBWay also offer other services like 3D printing, metal sheet fabrication, and injection molding, so it's pretty flexible, quite a few services available. I'm more than happy to recommend PCBWay for the quality of their PCBs, so take a look at PCBWay.com, the link is also down below in the description. Let me thank PCBWay for sponsoring this video. Their help makes these videos possible, so thank you very much, PCBWay. Now let's continue with the ZX Spectrum. Next step would be to replace the voltage regulator with something more modern that doesn't make so much heat, and also to perform the power supply modification, which was requested by Sinclair itself. So let's do that. And all the modifications are done, so it's now time to test it, make sure everything works. Then we'll do a little bit of TLC, adjust the video output, and maybe test it with some software. So let's power up first, make sure that everything is still up and running. 3, 2, 1, go. We have a beep. That should be a good sign. And yes, it is still working, which is good. Let's make sure that everything works, that the RAM test passes. And everything works, and I've just checked the output of the regulator here, and it's reading 5.06 volts, which is great, and obviously this is basically not making any heat at all. Next step would be for me to remove all the socketed ICs and spray some contact cleaner, reseat everything, and then we'll see if we can adjust the video output. Now I am ready to check the video output. Before I do that, I'll spray some contact cleaner on these horrible trim pots. They get stuck and crusty pretty easily. So before I adjust them, I'll just spray some contact cleaner and then I'll move them around. So obviously that will mess up the video, but I'm ready to adjust it. What you're seeing on the oscilloscope is the video signal. That line represents one of the lines on screen. You can see the sync signal, you can see the color burst, and then you can see the actual line, which it's mostly white, because obviously actually gray, because we are looking at what's called the paper of the ZX Spectrum, and the plan is to adjust the streamers here so that the line is as flat as possible. And that should be the best, which should correspond to a grey background. Now, I'm not sure how much my capture device is going to be faithful when it comes to that, but let's take a look. And it doesn't look bad at all, so that is great. Another fine adjustment, if you have an oscilloscope, would be to check pin 17 of these IC here for the PAL frequency, which happens to be 4.433619 megahertz. So let's power up and let's check on the oscilloscope what we have. Oscilloscope says 4.43354. We should be 6.1, so let's try and adjust this. I'm not sure how relevant this is, how important this is, but you know, let's try and do that. 4.43362. Perfect, so that is also done. The rubber key membrane has arrived. I've got this from Retrolium in the UK. If you need anything for your ZX Spectrum, Commodore 64 or similar machines, Retrolium is an amazing place. Phil is a great person, very helpful, and he sent me this. It's kind of amazing that this is still being manufactured. Now, it comes with a plastic tool and instructions to remove the faceplate, the metal faceplate, which unfortunately on this model is attached with double-sided tape. So that would take a little bit of time. I would get a hairdryer. Yes, I do have a hairdryer in the house. So I get that one because I could use my hot test station or even my heat gun. But considering this is rubber, I think it would be easy to damage something. I don't want to do it. Now, the good thing is that the metal plate here either has been pried off already because it's like half detached, or it's just came off with time. That would definitely help. That would give me a place where to start. So let's get the hair dryer and let's give this a go. Oh well. That was easy. Ta-da! Well, the keyboard looks brand new. It was actually easier than I thought, and I have to say it looks pretty nice. Let's make sure that everything works. Let's power up. 3, 2, 1, go. Well, everything seems to be working fine, which is great. There's not much left to do besides loading some software and make sure that everything works, and then we can put it back together and it'll be done. Now, while I was cleaning the audio inputs and outputs, I've noticed this resistor here, which is R35 on schematics, which looks like it's burned. And according to the schematics, that in series with the microphone, which I guess is an input. So I'm assuming someone might have fed the wrong signal at that input and the resistor burned for some reasons. That doesn't look right. Now, the other these two components here, I know they don't look like capacitors, but according to these schematics, they are. And I think this black things is by design, is to identify them or whatever. But the resistor is definitely not right. So I'd like to remove it and measure it and replace it anyways, because resistors can still work even though they are externally damaged. So we'll replace it anyways, but I'm curious to see whether that actually measures what it's supposed to read. And this is supposed to be a 10K resistor, so it is still working, but I think it's definitely burned. I would say that this is definitely burned. Those little blisters look like caused by high temperatures, so I'll definitely replace it anyways, and I hope that that was caused by something which shouldn't have been plugged into the ZX Spectrum. And yeah, I mean, the ULA definitely works, because that's the same that we're using on the other one that we repaired last time, so finger crossed, this is just a little preventive maintenance. The ZX Spectrum is ready to go, and the last thing I wanted to do was to load some software and make sure that everything works. Now, I don't have a mono mini jack connector as last time, so I have a little bit of patching here going on, and I've been trying to load something on this ZX Spectrum and also my other one for quite a while, and I couldn't figure out what was wrong with it. At some point, I connected the oscilloscope because I wanted to see what was getting to the ZX Spectrum. I understand the ZX Spectrum is a bit fussy when it comes to the level of the sound and the tone of the sound and all these things. But the thing is, I made it work before using a software called Otla, and I couldn't figure out what was different because it's my same laptop, it's the same file, the same software, and I even tried with the same ZX Spectrum and it still wouldn't work. And the oscilloscope really helped me understanding what the problem was, because when I went to load the software using my Windows software here, the waveform going to the ZX Spectrum begins at about 2.6 volts peak to peak, and a few seconds later it gets softer, down to about 900 and something millivolts, and you have a loading error on the ZX Spectrum here. Now, this behavior of the sound signal reduced in itself sounds like some sort of compression or maybe some sort of earring protection from Windows itself, because this is considered to be the headphone output. So what I did, I went into Windows settings under headphones, and I was looking for something, some kind of effect, enhancement, compression, whatever it is called. And I found these selection here that is enabled audio enhancement. And my experience is, unless it's really needed, that's best disabled. And once I disabled that, I went back to load the software as before, exactly the same software using the same software. And I've noticed that the oscilloscope is now crashed. So I went back to the ZX Spectrum and loaded the software again, exactly in the same way. And what I noticed is that the oscilloscope is now reporting a signal which begins at around 3.3 volts peak to peak and stays at 3.3 volts peak to peak even when the signal picks up. And guess what? The software is now loading. I have no error messages.
It's working. It's taken me, I would say, 2-3 hours to figure this out. I can't remember having this last time. It must be some kind of settings, maybe an update or whatever. What matters is it's working.
And it works. Well, I'm not even trying to play this game as my current capture device has about 3 seconds delay, so it's absolutely unplayable, but it totally works. I'm pretty happy with this repair, which was mostly a service than a repair with bits and bobs, but I'm pretty happy with the outcome, pretty impressed by these machines as last time. For 1982, that's absolutely amazing. Now, both my Spectrums are going back to their owner, Becca. Thank you, Becca, for trusting me with your Spectrums. Becca is one of my local viewers, so she will get the Spectrums back. Now, unfortunately, there's only one working ULA between the two, so I understand that the working one will go in the other one. And this one, well, at least we know that it's working, it's serviced, new capacitors, it's not like a small oven again, and it can be restored with just another ULA or ULA replacement. This was my last Spectrum in the pipeline, at least in the foreseeable future. I hope I'm getting another Sinclair at some point, because I'd love to learn more about these machines, because I don't know much about them. For now, that's it for today. I hope you enjoyed the video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. Please do leave a comment. I read them all and I try to respond to them all if I have time. Thank you for watching. I hope to see you again here soon on my channel for my next videos. For now, thank you very much and goodbye. Bye bye.